Welcome to another 3 Steps to Sketch. Today we're going to look at a pretty basic shifted cotangent graph. Y equals cotangent of x minus pi over 2. And we know it's a shift because we see in with the x that minus pi over 2. That's a big indicator that we have a shift and thus need to use our shifted method. So here's the outline for our shifted cotangent graph method. First, we'll find our essential information, get everything organized. Second, we'll plot our base pattern. We'll do this lightly because in step 3, we're going to take care of the shifts. Then we'll sketch in our final graph and repeat it for as many cycles as we need. All right, so as we get started, remember that our general form shifted cotangent equation is A cotangent of bx minus c plus d. So that'll help us when we get everything organized. All right, so now for step 1, when we find our essentials, our base graph, we want to identify A and B. So first we'll do A, the understood leading coefficient in front of cotangent is a 1. So this will help us find y coordinates for some of our points in our base pattern, our curve shaping points. B is the coefficient in front of x, another understood 1. That tells us we'll have one cycle of our graph happening between 0 and pi. It also helps us calculate our period, or the length of one horizontal cycle. And we do that for cotangent graphs using the formula pi over b. So here, pretty simple, pi over 1, our period is just pi. And now we're ready to decide how to label our axes, how to label the tick marks. So for our horizontal axis, we're going to choose our label as the period divided by 4, so that in step 2, each of our key points in our base pattern align nicely with our horizontal tick marks. So take that period, divide by 4, we'll count by pi over 4 for our horizontal axis. And for the vertical axis, we'll count by 1s. That usually works well. Take a quick look at A, make sure that makes sense, and it does in this case. So now let's label our graph, our grid, with our scale labels. Start with the horizontal axis, counting by 1 pi over 4. So we have 1 pi over 4, 2 pi over 4 reduces to pi over 2, 3 pi over 4, 4 pi over 4 reduces to pi. All right, take a quick pause here. This 4th tick mark to the right should match your period, and it does, so we are on the right track. And we'll keep labeling all the way to the end of our grid. So 5 pi over 4, 6 pi over 4 reduces to 3 pi over 2, 7 pi over 4, and 8 pi over 4, or 2 pi. So if you're working along with me, I'm going to pause and label the other side of the horizontal axis. It'll be all the same values, just negative. All right, so here's what that looks like. And then label your vertical axis, just counting by 1s. Easy enough, and then we have everything really nicely set up as we start to get into our graphing in the next couple steps. Before we do that, we do want to go ahead and identify our shifts, and we talked about this a little bit earlier. So we see that shift in the form of the minus pi over 2. We see that our term c must be pi over 2 in this case. I usually take a quick look to make sure that the sign in between the x and whatever other term we have in the parentheses matches this minus sign in the general form. If not, you just have to make a quick adjustment. A plus sign would indicate that your c term is negative because it's like minus a negative, which turns into a plus. But in this case, we just have a positive pi over 2 as our c, divided by b, which is 1. So our shift horizontally, or our phase shift, is pi over 2, which means that we're moving everything pi over 2 to the right. Since our horizontal scale is counting by pi over 4, this means that when we shift horizontally, we should shift everything 2 horizontal tick marks to the right. Okay, and then D, we don't have anything for vertical shift, so we're all good there. And now that we've talked about our shifts, the last thing I like to do is find that asymptotes equation. So it's very easy to do that. All you're going to do is take your inputs of your cotangent function for your equation, set them equal to the parent asymptotes of y equals cotangent x, and those happen at 0 plus pi k, where k is an integer. So a little scratch work here. So here are the inputs of our function, x minus pi over 2. Set them equal to 0 plus pi k. And you're going to solve for x. So just add pi over 2 to both sides. Add pi over 2. And notice that pi over 2 is not a like term with the pi k. So all we have to do is 0 plus pi over 2 on that right side. So we have x equals pi over 2 plus pi k. All right, we'll write that down here in our asymptotes blank, and we can substitute in different integers for k to see where our final asymptote should be for our graph. So for example, when k is 0, we are expecting an asymptote at pi over 2. Let k equal 1, simplify a little bit. We would expect our next asymptote to the right to be at 3 pi over 2. Similarly, let k equal -1, we're expecting another asymptote, this time to the left of our original, at -pi over 2. So this is just really helpful, going ahead and finding this. Sometimes that's all you really need to know for a problem. Other times, if you're graphing, this is a great way to double check yourself as you're developing and sketching your graph. All right, so now we're ready for step 2. Let's plot the base pattern. Remember, for cotangent, that's asymptote starting on the y-axis, where you have a curve shaping point, kind of that upper curve shaping point, a 0 or x-intercept, and then the lower curve shaping point. And we're going to mark this lightly, so I'll show this in light blue, okay, because this is not our final graph. This is before we do our shift. Okay, so we would have our asymptote. Our first curve shaping point happens at the first horizontal tick mark to the right. The y-coordinate of that point is simply our value a, so it's right there. Our 0 happens at our second horizontal tick mark to the right, and our final curve shaping point happens at the third one. Its y-coordinate is just the opposite value of a. So you can see the cotangent curve here. And again, just marking this lightly, this is not our final graph. We still need to take care of the shifts, and we'll do that now in step 3. All right, so for step 3, we shift, then we'll sketch in our curve and repeat. So take each of your points, including the asymptote, and all we're going to do is move everything right pi over 2 units, or right 2 horizontal tick marks. So starting with that vertical asymptote, move it right pi over 2. And this is our final graph. I'm marking it in green, so mark it darkly. Okay, now we'll take our first curve shaping point, move it right pi over 2, or 2 horizontal grid units. Do that with the 0 and the other curve shaping point. And you can sketch in your first cotangent curve. Now all we have to do is repeat this pattern. So here's our next asymptote. Notice it happens at 3 pi over 2. We predicted that with the asymptotes equation. And you can confirm we also had talked about pi over 2 from that first cycle. And we're just repeating this pattern over and over again. Work to the left now. So you can work backward, or you can just count 4 units to the left and then restart the pattern, whatever's easiest for you. There's that asymptote when k is -1. Happens at -pi over 2. All right, work backward again. If you let k equal to -2, you would get your asymptote here at -3 pi over 2. Sketching another cycle. And a little partial cycle here to finish out. So here we have almost 5 full cycles of our graph cotangent of x minus pi over 2. Now it's worth noting, we said at the beginning, this is a pretty basic shifted cotangent graph. All it is, looking at the equation, is moving everything from your parent graph, cotangent x, right pi over 2. So if you wanted to do this as just a basic transformation on the parent function cotangent graph, you'll notice we essentially sketched that graph lightly in step 2, that light blue graph, and then we moved everything right pi over 2 units. That's another great way to work this, and I'd say probably the way I would choose if I were doing this problem in isolation. Now, we worked it through using the full method so that you can see how the method works with a relatively easy shifted graph, and that way you're ready to tackle any of the tougher shifts that you might see for cotangent x graphs. All right, so hope that helped. I'll be sure to post links to the full cotangent playlist. It has examples of basic unshifted cotangent graphs, and it'll have a lot more examples of shifted cotangent graphs. And you also can find in the video description links to graphing all of the other trig functions. So be sure to check those out, and thanks for watching.